Please. So, our warm-up was to sketch the square root function and the cube root function. See if I am working up. There we go. I'm talking stuff. So, let's get a copy of those two functions. If you forget what they look like, you can always make an exercise table and plot some points to help you. Quiet, please. So the square root function, if we think about it, what is the square root of 1? It is 1. So it will have the point 1, 1. And then I would skip over 2, 3, 4 because that's my next perfect square. The square root of 4 is what? 2. That helps me get my points correct. So it looks like that. There's our square root function. If you are uncertain about the cube root, again, some points to help you. You should already have the sketch from our graph that we already did in the warm-up, but let's just get it right. So, the cube root function is y equals the cube root of x. So what is the cube root of 1? Yes. So we have that point. And what is the cube root of negative 1? Correct. So we have this point. What's the cube root of 0?
0.
And then the next cube root, perfect cube that we have is what?
9.
8. It is 8. So if we go over to 8, what's the cube root of 8? It is 2. And the cube root of negative 8 is negative 2. So that's where this shape comes from, if I can do that here as well. Okay, that wasn't too bad. All right, so those are the main two functions that we're going to be shifting and stretching today. So, if you come across any others, like a 5th root or a 7th root in the homework graphics, you see that it will look similar to this, but flattened out a little bit. But if you have any trouble thinking of what the parent function looks like, use your calculator so you can see it, and then start your shifting and stretching. Okay? All right. So those are the two we're going to play with most today. So our section is 6-8, and we're graphing radical functions. Our objective is to graph square root and other radical functions using our shifting and stretching skills from the previous chapters. So, what we have here is just some reminders of our transformations. If our parent function is the square root, we write y equals the square root of x. And then any other root, we can write y equals the nth root, depending on what that is. The cube root, the 5th root, the 8th root, any of those. So let's remind ourselves, if we put a negative in front of the function, what does it do? Reflects over the x-axis. The stretch is the one that gets you guys most nervous. We're going to mainly deal with the stretch out in front. So the vertical stretch instead of the stretch inside the square root, because those are a little harder to grasp. So our focus is going to be with the vertical stretch. So if a is greater than 1, it is a stretch. You're stretching it vertically. If a is between 0 and 1, which means it's a fraction that's less than 1, 1/2 or 1/3, then you are shrinking it vertically by a factor of a, by a factor of 1/2. So if there's a 1/2 in front, you're squishing it vertically. You're multiplying each y value by a half. Okay? All right, and then our translations for horizontal and vertical. What does this do? -8, what would that do? So let's say we have the square root of x minus 4 plus 7. How did that move the square root function?
To the right.
Yes. Inside the function is opposite of what you would expect, so this one is to the right 4. You would think negative and then to the left. So it's the opposite, right 4. And what does this one do? Up 7. Exactly what you would expect for the vertical shift. And the same shifting happens no matter what the radical is. Okay? All right, any questions on those? Take a minute, make sure you have... So our first example, we are going to, remember these are called translations and transformations. We're going to translate a square root function vertically. So, if my original function is the square root of x, which we've already practiced twice graphing, so I'm just going to do a quick sketch of it here. Here's my original, square root of x. What happens to it when I do the square root of x minus 2? Down 2. So what you need to do is find those points that we know exist. Fellas, look at the point. Stay with me. 0, 0, 1, 1, and 4, 2. Those 3 points are the ones you should shift down to. So this one goes down to here. This one goes down to -1. And this one goes down to 0. So that one looks like it is there. Okay? If you just sketch it in without those points, I'm not going to give you full credit. You need to show me that you know the exact points to get to that new translated function. All right, what would the square root of x plus 1 do to our original? A point, yeah. So take each of our 3 anchor points and move them up 1. So that means we'll have 1 and 3 here, and we get not the scale, but we get that. Okay? Easy shift. Just make sure to show me the points that you're moving. And remember, you're moving the original parent function. In this case, the parent is y equals the square root of x. That's the one we're shifting. Okay? Questions here? All right, it should be mainly a review. So here's the example of what we did on the graph paper. We took this one and shifted it down 2, and we took the original and shifted it up 1.
How many of those points do we have to show you?
Well, we talked about those points that we knew for the square root, so 3 points with the square root function. And then I would be happy with -1, 0, 1. I'd be happier up to 2. -2 to 2 on a series. Okay? All right, so this time, horizontally, what is this one going to do? 0? Left 4. Left 4, and this one? Right 1. So if we look at the actual functions, here's our original. The first example we did, we take this one, and that one, and move each of them left 4. 1, 2, 3, 4. So there's our new point. 1, 2, 3, 4, our new point, and our other new point. Okay, and then right 1, I can see that point move, that one, and that one. Okay, easy enough? The horizontal and vertical translations are more straightforward. We have less trouble with that than we do when we start stretching them. So let's talk about one where we have to stretch it. So on this one, we're graphing a square root, and it has a reflection, it has a vertical compression, it has a shift to the right, and it has a shift up and down. So here's where you need to write yourself a little note. Take care of the reflection and the stretch first. The reflection and the stretch. And I would probably say first do the stretch or the shrink. And second do the reflection. And then do your translation. So in the picture that we have here, they did the first two steps, my first two steps, in one combined step. So here's the original, the square root of x. What does the negative do? Deflects it over the x. What's the 1/2 do? There's our vertical compression. So I would first do that vertical compression, and I would take each of my key points and multiply them by 1/2. So 0 times 1/2 is still 0. 1 times 1/2 is 1/2, and 2 times 1/2 is 1. And then I would reflect those 3 points across the x-axis. And that's what they have here, here, and here. Then once you have that, it's far easier to move it right 3, take each of those points, move right 3, and up 1. This one moves right 3, and up 1. And this one right 3, and up 1. Okay? All right. Get your calculators out, please. I would like you to, let's read this problem first. You can model the population P of corporate inhabitants between 1970 and 2005 with the radical function that's given, where x is the year. Notice they say it is the year, so it's not going to be putting in 70, 80, 90, it's the whole year, 1970, 1980. Using this model, in what year was the population of Corpus Christi 250,000? So I want to practice doing this with our calculators and using the method where we find the intersection. So let's make sure we have our function first. You should have your calculator out. It is 75,000 cube root x minus 1950. So in y equals, if you don't have a calculator, get up and get one, please. Ian, go get one, please. If you don't have yours. Anybody else? So you can borrow the pink one. Don't need
Oh, boy.
Now, our window is going to be the part we have to be careful about on this. So it was 75,000 times the cube root. How do I get cube root? Math, and then what? Which is 4. Cube root of, does anybody remember what it was? X minus 1950. Okay. And then in here, I'll put in parentheses, x minus 1950, close my parentheses. So it should look like that.
You have to close the parentheses.
I believe your calculator allows you to stay under the root without the parentheses, so it's good practice. All right, so if I were to do Zoom 6, would this show up? We're talking about really big numbers. And we are interested in when this is equal to 250,000. So what I want you to do is in Y2, put in the 250,000. So what we can do, if we want to find when this population is equal to 250,000, we can find the intersection of these two graphs. But we need to get the intersection in our window. So let's set up our window. We definitely need to have 250,000 in the middle of our window. All right, so let's go to window. What are our x values going to be like? 1, 2, 3?
No.
No, they'll be what?
More than.
So well, they will be more than 1, 2, 3. We're talking about years starting in 1970. So let's start this at, let's go a little lower than that. Let's do 1965. You also want to go a little lower than the lowest. Up to it said 2005, so let's go up to 2010. And what would be a good scale? Because 1 would not be great.
20.
20s are good. 20s are good. All right, and what about our Ys?
A lot.
Yeah, we need to get 250,000 in there.
70,000.
I would
60,000.
start at maybe 210,000 up to 270. So I've got 250 right in the middle. And what about my scale? I'm going to go by. I'm going to go bigger. These are 10,000 hearts. I'll say 150. And I'm going to press graph. Not bad. So there's our Y1. That's our cube root function. And here comes our 250,000. So by setting the window correctly, before you graph it, it's right there in the middle of our screen for our intersection. Okay? How do we find an intersection? Yep. Mackenzie, what is it? Second calc. Number 5. Intersect. And on this one, all you do is use the left and right buttons to put your cursor right on the intersection. It asks, is this the first curve? And it's showing our Y1, and we say yes, so we hit enter. And is the red line our second curve? We say yes, so we hit enter. And then it's saying, shall I guess? And you say yes. So, when will the population be 250,000? 1987. Yeah.
So on my calculator, I put in like 250,000 for Y2, never graphed that right.
Double check your window. Oh, is it only graphing one of the 2 equations? I'll have to reset from the Okay. All right, questions on this one? All right, so let's go back to our choices. It was a multiple choice question. What's our best answer? 1986. Okay? All right. And I wanted to have one example of a cube root shifted. So remember to do your stretch first. So take each of our points that we know, 0, 1, 1, 1, and 8, 2, 0, negative 1, and negative 8, negative 2. We're going to multiply each one of our y's by 2 to start. So 1 times 2 is 2, so that one is now here. 0 times 2 is still 0, and 2 times 2 is 4. So we're up to here. Same thing down here. And I'll do it in dash because this is not the final. But that is the one that we need to now shift. And how does it shift? Left 1. And what's that one do? Down 1. Down 4. So take each one of these points, and we'll go off our graph, but we'll show it anyway. Take each of our points and go left 1 and down 1, 2, 3, 4. So there's our new point for that one. Left 1 and down 1, 2, 3, 4. There's that one. Left 1 and down. Sorry, each one of these is worth 2. Left 1 and down 2 should be here. It will be on our screen. Left 1 and down 2 would be here. Left 1 and down 2 would be there. Left 1 touch please. And down 2 would be here. And left 1 and down 2 would be there. So we get there's our new function. Okay? Showing each of our points.
What is down 4?
Was it down 4? Oh,
You
yeah.
decided to take down 2.
I did, because each one was worth 2. Let's try it again. So we take each of these and multiply by 2, that's the bar. And that was okay. All right, so my dashed line, there is the one that I need to shift. And it is left 1 and down 4. So let's take each of them. Left 1, each of these are worth 2, so that's half a box. And down 4. That's 2 boxes. Would be there. Left 1, down 4 is there. Left 1, down 4 is there. Left 1, half a box, down 4. And left 1. Thank you, that's better. All right. And I think that's it for our example. So I'll get the homework up. Let's see if I have it.
All right, so homework for today, 6-8.
You're doing page 418, 7 through 31 odd. Got it. 418, 7 through 31 odd.